In a land where nearly 50% of the area is harsh desert, while water resources are continuously pushed into a state of red alert, California has still created an unprecedented miracle in modern agriculture, producing more than 70 million tons of agricultural products every year, while dominating the food supply chain that feeds over 340 million Americans. So how have American farmers been able to turn those arid lands into one of the most abundant agricultural hubs on the planet? That is what we will explore in this episode. California, by nearly every measure, is a true powerhouse. Yet it is also a state carrying a fatal weakness within itself. Nearly 39 million residents live in a place without water. The paradox is that although nearly half of the state's total area is covered by desert and arid land, California is not only home to two massive coastal urban regions, but also the agricultural heart of the United States. Nearly all of America's leafy greens during winter come from Imperial Valley. Meanwhile, Central Valley produces nearly 40% of the nation's fruits and nuts, even though the region accounts for only around 1% of total U.S. farmland. By natural logic, this should have been one of the most difficult places in the country to develop agriculture. So, how did California achieve it? Part of the answer lies in advantages few places possess. California is almost a perfect natural blueprint, with a rare Mediterranean climate and more than 300 sunny days each year. In addition, more than 700 miles of the California Aqueduct, along with systems such as the Los Angeles Aqueduct, the Colorado River Aqueduct, vast irrigation networks, and groundwater extraction have pulled water from the north, from melting mountain snow, and from distant rivers to feed dry valleys. California did not wait for nature to allow it. It forced nature to serve it. But every system built to defeat nature comes at a cost. California's agricultural achievement is both a victory over natural limits and a growing contradiction. Agriculture now consumes about 80% of the water used by humans in the state, while the population continues to rise and the climate grows hotter. That is why the greatest debate in California is not whether agriculture has succeeded, but rather this question: how to divide a finite water supply among farming, cities, and the future of the state itself. Because despite every pressure, the fields here have never stopped operating. And to understand why that miracle still exists, we must begin with the very harvests that continue each day to resist the limits of this land. The journey of California's agricultural machine can begin with one of the most demanding yet most beloved fruits in the world: strawberries. Strawberries are extremely delicate and can be bruised after only a few minor impacts. So harvesting is almost a brutal race against time. As the sun rises, thousands of workers are already bent over the planting rows, hand-picking only the berries that have reached perfect ripeness. An experienced worker can harvest hundreds of pounds per day, earning around $18 per hour or more during peak season. With strawberries, the moment they are picked is the moment the race begins. While many states have only a short strawberry season lasting around 4 to 8 weeks, California can maintain harvests for 8 to 10 months, even nearly year-round in some coastal regions, thanks to its mild climate and overlapping production zones. This is an advantage no competitor can replicate. The state currently produces around 90% of total U.S. strawberry output, with more than 1 billion pounds per year, far ahead of every other state such as Florida or North Carolina. The commercial value alone often exceeds $2 billion annually, making strawberries one of the highest value fruits in the state. Those trays of strawberries are then moved immediately into cooling facilities, sorted, packed, and loaded onto refrigerated trucks within hours to reach distribution centers across the United States. From supermarkets, dessert chains, and restaurants to yogurt brands, ice cream, smoothies, jam, pastries, and countless processed food lines, all depend on the continuous daily flow of fresh California strawberries. From an ordinary fruit in the American market, avocado has exploded into a symbol of brunch culture, avocado toast, guacamole, and a billion-dollar healthy living trend. Originating from the ancient lands of Chile and Peru, avocados later surged strongly in Mexico before entering the modern North American market. Today, California is the largest avocado-producing center in the United States, dominating around 90% of domestic output, with roughly 300 million pounds per year, depending on the season. Unlike strawberries that can be replanted quickly, avocado is a perennial tree that requires 3 to 5 years before reaching commercial yields and demands a stable water supply through every season. On average, each avocado requires about 320 liters of water to fully develop, a figure that has sparked major controversy in California during prolonged drought periods. During the harvest season from around February to September, workers must use clippers to cut each fruit by hand, gently place it into bags worn on the chest, then transfer it into large bins to avoid bruising the skin. From there, avocados are sent to processing facilities to be washed, sorted by size, controlled for even ripening, and packed before being loaded onto refrigerated trucks headed to supermarkets across the United States. In a state facing both water shortages and mounting consumer waste, even avocado byproducts are being turned into new resources. California generates more than 40 million tons of waste each year, with single-use plastics posing a major challenge to recycling systems and coastal environments. As a result, avocado skins and pits after processing are being utilized at around 30% to produce bio-oil, cosmetics, compost, and many environmentally friendly biomaterials. Would you be willing to pay 1.5 to 3 times more for these green products instead of conventional plastics? No crop represents California's prosperity and the water cost behind it more than the most hated nut in America: almonds. California is currently the largest almond center in the world, supplying around 80% of global output and nearly 100% of U.S. production for many years. Each year, the state produces more than 2 to 3 billion pounds of almonds, with export value reaching billions of dollars. California's almond orchards are not sustained by rain. They are sustained by water carried from hundreds of miles away, flowing through drip irrigation lines with almost absolute precision. Every late winter and early spring, a massive biological migration takes place. More than 2 million honeybee hives from across the United States are transported by truck to California to pollinate millions of acres of almond orchards blooming at the same time, one of the largest pollination operations on the planet. During harvest season, usually lasting from around August to October, giant tree shaker machines clamp tightly onto the trunks and shake them violently for a few seconds so that all almonds fall onto the ground, which has been cleaned beforehand. After that, sweeper machines gather the nuts into long rows between the orchards, and pickup machines vacuum the entire layer of still-shelled almonds into storage compartments. From there, the almonds are sent to factories to remove the outer hull, dry them, sort them by size, inspect quality, and package them before being exported worldwide. But no crop has been criticized more than almonds. On average, producing just one almond may require around 3 to 4 liters of water. The problem is that almonds are a perennial crop. Once planted as orchards, farmers are forced to keep irrigating year after year to protect an investment that spans decades. With almonds, California cannot simply turn back. Its very success has locked in the choices of the future. If almonds represent wealth and controversy, then tomatoes represent California's pure industrial power. During the harvest season from around July to October, giant tomato harvester machines move straight into the fields, cut entire plants from the ground, then shake the fruit loose inside the mechanical system. Leaves, soil, and debris are removed while conveyor belts continuously dump tons of tomatoes into trucks driving alongside. In a short period of time, entire fields can be harvested cleanly, helping generate more than 10 to 12 million tons of processing tomatoes each year. But harvesting is only the first step. Because tomatoes ripen quickly and lose quality easily, trucks often drive directly from the fields to nearby factories. From ketchup in fast food chains, sauce on frozen pizzas, pasta sauce in supermarkets, to canned soup and convenience foods, millions of Americans consume California tomatoes every day without ever seeing where they began. California is currently the largest processing tomato center in the United States, often supplying around 90% of the nation's processed tomato volume. That is the paradox of California tomatoes. Less romantic than the image of traditional farms, yet one of the most efficient agricultural machines ever built. America rarely notices lettuce until store shelves suddenly go empty. From burgers, sandwiches, and salad bowls to fast food chains and convenience stores, lettuce appears almost everywhere. With its delicate and temperamental nature, lettuce is also one of the agricultural products that demands the highest speed. During harvest season, which takes place nearly year-round thanks to overlapping growing regions, cutting machines or manual labor crews move continuously through the fields, cutting lettuce, packing cartons, and transferring them immediately into cooling systems within a short time. Because lettuce contains a high amount of water and loses crispness easily, every hour of delay causes quality to decline rapidly. Those cartons of lettuce are then loaded onto refrigerated trucks, leaving the fields for distribution centers, supermarkets, and restaurants across the United States. From the moment it is cut from the root to the moment it appears in a burger or salad bowl, time is always the deciding factor. Regions such as Salinas Valley, Monterey County, and Imperial Valley create an overlapping seasonal production chain, supplying around 6 to 8 billion pounds of lettuce each year, and helping this vegetable remain available almost year-round across the American market. However, because it is consumed fresh and almost never cooked, lettuce also carries higher food safety risks than many other agricultural products. When lettuce faces a problem, the entire United States suddenly realizes how dependent it is on it. That is what makes California lettuce unique. Little glamour, little attention, yet operating like a gigantic logistics machine. With just the push of a button, you can instantly produce fresh, nutritious feed for livestock. There is no waste, year-round production, and up to 95% water savings compared to traditional fields. It sounds like a fairy tale, but it is already a reality. On the screen is a vertical hydroponic system designed to improve long-term farm efficiency, something that becomes even more meaningful as the world faces a growing shortage of meat. Even better, this system is environmentally friendly. Higher quality feed can help cattle emit less methane. The system is called HydroGreen, and it comes in multiple configurations. For example, systems designed for 100 or 1,000 head of cattle. Seed sowing, irrigation, and lighting are all controlled by smart automated components. 2 starter-level HydroGreen units can produce around 1,300 pounds of feed per day, while 12 more advanced units can replace approximately 400 football fields of conventional farmland. We are facing an urgent problem that must be solved. the group shared. Can you guess what they were talking about? In the near future, we may no longer be able to keep food prices affordable, simply because our natural resources will be depleted. It is time for a new way to feed the world, or put more simply, a new kind of mobile farm. Instead of expanding on land, they developed a system called Nemo's Garden, a series of dome-shaped greenhouses installed at depths of 5 to 10 meters below the sea surface. Each dome holds up to 2,000 liters of air, maintaining nearly 100% humidity and creating a stable, year-round environment for plants using a hydroponic system. In their experiments, Nemo's Garden successfully cultivated over 40 plant species, with basil showing an increase of up to 31% in antioxidant content compared to soil-grown plants. Thanks to natural underwater pressure and stable temperatures, the system can operate fully automatically without soil, free from most land-based pests, and with almost no need for pesticides. Leafy greens are a foundation. But to truly feed the world, humanity needs much more, especially reliable sources of high-quality protein. And on the open ocean, Norway is leading the charge with a next-generation offshore fish farm. Not far behind, China has also stepped in, acting as a bridge for international partnerships, technology exchange, and the rapid expansion of deep-sea aquaculture. This system operates like a giant steel farm in the middle of the ocean, engineered to raise salmon on a scale the world has never seen. In its initial phase alone, the structure can hold over 22 million pounds of salmon, providing an enormous supply of protein for global markets. Stretching 1,236 feet in length, taller than the Eiffel Tower if stood upright, the facility is divided into 6 independent rearing tanks, each designed for a different stage of the salmon growth cycle. What makes the project exceptional is not only its scale, but its resilience against nature. The structure is built to withstand 33-foot waves, and in severe storms or extreme conditions, the entire platform can be elevated an additional 13 feet to reduce wave impact. All of this is designed to protect the fish and maintain continuous farming operations 24/7. Behind this ambition is an investment of 197 million USDs, signaling a bold commitment to transforming the ocean into the protein fields of the future. Still on the topic of fish, if your business works in municipal or commercial water supply, innovations like this are absolutely within reach. On the screen is a 12,500 square foot tilapia farm, supported by specialists from a U.S. aquaculture company. The team is evaluating the performance of this grow-out cycle. 242 days ago, they stocked the tanks with juvenile fish, and now those fingerlings have grown into market-ready adults, weighing between 1 and 12 pounds. The facility is built around 5 independent recirculating aquaculture systems (RAS), a modern approach that dramatically reduces water use and maintains ideal water quality with minimal waste. Thanks to closed-loop filtration and continuous monitoring, the farm achieved a 2% mortality rate, far better than the original 10% expectation, resulting in a significantly higher profit margin. Production has scaled so efficiently that part of the harvest is already scheduled for long-distance distribution, including a shipment bound for China in time for Lunar New Year. Ordinary bridges can feel dull and uninspiring, so why not transform them into living works of modern art? If you assume such projects are costly or slow to build, think again. This bridge in Germany has become a seasonal icon for its city, drawing attention every spring. Originally constructed in 2000 for an exhibition, the bridge tunnel stretches 49 feet in length, weighs roughly 41,888 pounds, and requires 2,160 individual plant pots to complete its design. Among them are violets, lavender, sage, and wallflowers, creating both visual texture and a natural fragrance. From April onward, residents and visitors can walk through and enjoy a multi-sensory experience. The concept behind the installation is simple yet striking, a harmonious fusion of art, nature, and technology, turning an everyday structure into a public masterpiece. The next project is just as fascinating, a vertical farm that can be built anywhere in the world. It delivers astonishing productivity, up to 350 times more yield per acre compared to traditional agriculture, with a unique modular design and the ability to produce high-quality food all year round. It's no surprise that Driscoll's, a company that once controlled 1/3 of the U.S. berry market, became a strategic sponsor. One of the manufacturer's mottos is, "A farm is only as good as the equipment it runs on." So if our smartphones are more powerful than the computers that sent humans to the moon, then why not apply advanced technology to agriculture? The result is a robotic farming system powered by PlentyOS, using special foam pads instead of soil, along with sensors, AI, and a fully automated robotic operation. Thanks to that, leafy greens such as cabbage, onions, basil, and even berries achieve outstanding yields, with strawberries alone reaching 4.5 million pounds per year. Traditional poultry farms typically house around 15 to 17 chickens per square meter, but with the modern farming model developed by Fit Farm Innovation Team GmbH, that number can be up to 2.5 times higher, while still maintaining animal welfare and operational efficiency. The standard setup is engineered with optimized ventilation, easily replaceable components, and the ability to integrate robotic arms into the production line when needed, from care and feeding to harvesting. Fit supports clients through every stage, from planning and installation to full operation, with configurations that comply with European Union standards. By 2025, Fit's system will be deployed across more than 20 commercial-scale farms throughout Europe, particularly in Germany, Austria, Poland, and the Netherlands. With the continued growth of the EU poultry market and rising demand for protein, Fit is regarded as one of the most practical, efficient, and rapidly expanding models among next-generation livestock technologies. Next comes another standout project, a new model of sustainable agriculture. The innovators behind it believe the time has come to upgrade farming with robotics and artificial intelligence. The result is a fully automated farm that leaves viewers stunned. According to the development team, a 43,000 square foot facility can deliver the same output as a 1.3 million square foot conventional farm. Robots handle all labor-intensive tasks, from lifting and transporting to planting and transplanting. And by placing these farms close to retailers and marketplaces, food loss is dramatically reduced. Today, nearly 40% of fruits and vegetables spoil before reaching consumers. So shortening the supply chain becomes a critical advantage. According to United Nations statistics, even before the pandemic, around 690 million people worldwide were suffering from hunger, more than 10 times the population of France. That is why one of humanity's most urgent missions is to overcome the global food crisis. In response, engineers and scientists have developed mobile farms capable of operating in any climate. Each farm is built inside a 40-foot container, divided into 3 zones: a workstation for operators, a cultivation area, and a compartment for equipment and utilities. The performance is impressive. A single container can yield 4,400 pounds of cucumbers per year and is capable of growing more than 300 different crops, including medicinal plants. Each unit can operate for up to 10 years, and the Plant Keeper system allows users to monitor and control the entire farm easily through a smartphone. Standing out as one of the most iconic symbols of autumn, the pumpkin becomes the opening character in our harvest journey. Across the United States, with Illinois holding the title of pumpkin capital, vast golden fields come into season from late September to November, just in time for the excitement of Halloween. Fresh pumpkin harvesters use sharp blades to cut through thick stems, while mechanical arms lift the massive pumpkins from the ground and place them onto conveyor belts. Rotating rollers and brushes remove excess soil before the plump pumpkins are neatly deposited into storage bins at the rear. With a continuous rhythm, thousands of pumpkins are gathered within just a few hours. Unlike fresh pumpkin harvesters, pumpkin seed harvesters have a more specialized design. These machines crush and separate the entire fruit directly in the field, sorting out the seeds through screening systems, while the rind and flesh are discharged back onto the soil as organic fertilizer. By combining these two technologies, American farmers not only meet the enormous demand for fresh pumpkins in holiday markets and food production, but also maximize economic value from the seeds, driving annual yields to more than 680,000 metric tons. Farewell to the diligent farmers across the fields of Illinois. Now let us journey to Wisconsin and Massachusetts, where every September, farmers harvest their rewards, glistening like crimson jewels upon the water. Unlike pumpkins, cranberries are harvested using a unique method known as wet harvesting. When the season arrives, farmers flood the bogs with water, then deploy special machines called water reels or egg beaters to stir the vines and loosen the berries. Thanks to tiny air pockets inside, cranberries rise and float, creating a spectacular sight. Thousands of bright red berries drifting like a floating carpet across the water's surface. Next comes the conveyor harvester, a modern harvesting machine that drives directly through the flooded bog. At the front, steel tines sweep the floating berries into the intake, while rotating conveyors lift them up, drain the water, and deposit them straight into boats or bins along the bog's edge. This method accelerates collection, reduces the need for manual boom corralling, and minimizes damage, making it ideal for large-scale cranberry farms in the US and Canada. Much like the bison roaming the Great Plains, the sight of flooded bogs shimmering with cranberries has become an enduring symbol of North America, a living image that captures both its natural abundance and cultural identity. Another approach that is becoming increasingly widespread is the conveyor harvester, which demands an investment of $250,000 to $400,000, but delivers far greater efficiency. At the front, steel tines sweep the floating berries toward the intake, where rotating conveyors lift them up, drain away the excess water, and deposit them directly into waiting boats or bins along the bog's edge. Each year, harvesting 700,000 tons of cranberries can require millions of liters of water, but Ocean Spray, the largest farmer-owned cooperative in the United States, emphasizes that much of this water is reused throughout the season, while accounting for nearly 70% of the nation's production. Brussels sprouts grow in tall, sturdy stalks that can reach up to a meter in height, with dozens of compact green buds tightly clustered along the stem, making their harvest a task that requires both precision and specialized machinery. From September to March each year, the Brussels sprout fields in Flanders, the agricultural heart of Belgium, enter their harvest season. Farmers rely on specialized machines such as trailed Brussels sprout harvesters and self-propelled Brussels sprout harvesters. Inside, 6 rapidly rotating blades spin like a giant pencil sharpener, trimming each compact sprout and pushing the stalk forward. Every 6 seconds, one plant is fully processed. The Brussels sprouts are then cleaned by fans and filters before falling into the collection hopper. Thanks to scientific farming methods and highly efficient mechanization, Belgian farmers harvest more than 156 million pounds of Brussels sprouts each year, surpassing other countries such as the Netherlands, Germany, and the United Kingdom. Nearly 90% of the products we use every day contain sugar, and much of that sweetness begins in the sun-drenched sugarcane fields of Brazil, where farmers harvest around 650 million tons of cane each year. During the 2025 season, Brazilian farmers must race against time to cut and process sugarcane before it is sent for crushing and export. Before the 2000s, both American and Brazilian farmers commonly burned sugarcane fields before harvest, especially in São Paulo state, which produces more than half of Brazil's output. It might sound unusual, but the purpose was to remove dry leaves and unnecessary tops. This left the stalks cleaner, reduced excess debris such as fallen leaves, organic matter, and insects, and made manual cutting faster and more efficient. However, because of the enormous amount of smoke and harmful emissions it generated, Brazil has implemented a program to almost completely eliminate pre-harvest burning, shifting instead to mechanized green cane harvesting. But in the United States, especially in Florida, burning sugarcane before harvest is still common. If you were there, how would you explain the reason behind it? Against this backdrop, harvesting fresh, unburned sugarcane with modern machinery is increasingly being promoted and has quickly become the dominant path forward. Specialized harvesters cut the cane close to the ground, while simultaneously stripping leaves and tops right in the field. The stalks are lifted onto trucks by conveyor belts and transported straight to the mills on the same day. If the harvest is delayed, the sugar content in the cane drops rapidly, making it prone to mold and pests, which reduces its market value. That is why Brazilian farmers always strive to deliver the cane to the mills within 24 hours to ensure the best quality. Across Europe, Russia, and the northern United States, vast sugar beet fields stretch endlessly, with the harvest season running from September to November. Modern sugar beet harvesters are massive self-propelled machines designed with high precision. At the front, lifting wheels or digging shares penetrate the soil, gently raising the beets from the ground without breaking them. Immediately afterward, fast-spinning knives slice off the green tops, which are left in the field as a natural fertilizer. The beets, once cleaned and neatly trimmed, travel along a conveyor system, passing through a series of rollers and cleaning turbines that remove excess soil and stones. Finally, they are deposited into a large holding tank on the machine. While sugarcane still dominates with nearly 80% of the world's sugar supply, sugar beets provide the remaining 20%, with the European Union, Russia, the United States, and Turkey among the leading producers. China dominates the global plum industry, producing more than 6 million tons annually, over half of the world's total output. From July to September each year, farmers race against time to harvest their fruit at peak ripeness. Harvesting plums requires a delicate balance between speed and care. In small orchards, workers pick by hand, gently twisting the fruit from the branches to preserve the thin skin and juicy flesh. The harvested plums are then collected into baskets and moved quickly to sorting stations. In larger farms, such as those in California, mechanical shakers are deployed. These machines grip the trunk or main branches, delivering powerful shakes that send ripe plums tumbling onto catching frames or padded nets below. The fruit is then sorted, graded, and packed within hours to maintain freshness. Beyond being eaten fresh, plums are dried into prunes, processed into jams, or fermented into wines and spirits. Altogether, the global plum and prune industry carries an economic value of more than 10 billion USD, giving this fruit cultural and commercial importance far beyond the orchard. For thousands of years, the olive tree has stood as a symbol of peace and prosperity across the Mediterranean. By 2025, global olive production is expected to exceed 23 million tons, harvested from September's green fruit to January's black oil-rich olives. Among them, Spain continues to dominate with more than 8 million tons each year, far surpassing Italy and Greece, thanks to the millions of hectares of olive groves in Andalusia and the region's early adoption of advanced mechanization. To meet this massive demand, traditional hand-picking methods have been replaced by modern harvesting machines. One of the most impressive is the Pellenc Expand R5090, a true technological beast. Its massive yellow catching frame extends up to 10 meters, wrapping around the base of the tree. A powerful hydraulic shaker then vibrates the trunk and branches, sending ripe olives cascading down like rain. The fruits are immediately carried onto conveyors that strip away leaves, remove debris, and transfer clean olives directly into storage bins. With a capacity of 4 to 5 tons per day, this machine replaces the work of dozens of laborers, making it especially effective in large-scale groves across Andalusia, Tuscany, and Crete. However, the next leap forward comes with self-propelled olive harvesters like the New Holland Broad series, designed specifically for super high-density orchards. Instead of shaking each individual trunk, these machines drive directly through densely planted rows, using dual shakers and conveyors on both sides to gently strip away 15 to 20 tons of fruit per day from the canopy. In terms of yield, a modern hectare of olive trees can produce 3 to 5 tons of fruit, equivalent to around 600 to 800 liters of extra virgin olive oil, depending on the variety and growing conditions. From there, millions of tons of olives are transformed into extra virgin oil, cosmetics, soaps, and even biofuels, fueling an industry worth more than $15 billion annually. Truly, olives remain the liquid gold of the Mediterranean. Delicate and easily bruised zucchini, also known as courgette, is one of the most fragile vegetables to harvest, yet it is considered among the easiest crops to grow in the world. Within just 45 to 60 days after sowing, the plants begin to produce fruit, and throughout the season, farmers must harvest almost daily to keep each zucchini tender, crisp, and at its highest market value. Farmers use small knives to gently cut the stems, taking care not to damage the thin, sensitive skin. Left on the plant for just 1 or 2 extra days, the fruit can grow 3 to 5 centimeters longer, becoming oversized and losing commercial value. Today, the United States, Italy, Spain, and Mexico are among the world's largest zucchini producers. The United States alone harvests over 400,000 tons annually, while the European Union produces more than 1.1 million tons in total. Thanks to its rapid growth, continuous yield, and strong consumer demand, zucchini has become one of the 10 most widely cultivated vegetables worldwide. Today, more than 90 million beehives worldwide produce around 1.8 million tons of honey each year, supplying markets from Asia to Europe and North America. From May to September, the peak harvest season takes place across the Northern Hemisphere, when beekeepers carefully lift heavy honeycombs from their hives to collect nature's liquid gold. Smoke from a traditional bee smoker is used to calm the colonies and reduce the risk of stings. Each frame is then gently removed, often covered with thousands of bees. On average, a single frame can hold 2 to 4 kilograms of honey. The beekeeper must work quickly and precisely, brushing the bees away before placing the frames into sealed transport boxes. Globally, beekeeping is thriving. China leads the industry, producing over 450,000 tons, nearly 25% of the world's honey supply. The United States, Turkey, Argentina, and India also rank among the top producers. In Europe alone, more than 600,000 people are involved in apiculture, not only for honey, but also because of bees' crucial role in crop pollination. Once harvested, the honeycombs are delivered to processing facilities. There, the thin wax cappings are sliced off by hand knives or automatic uncapping machines. The frames are then placed into centrifugal extractors, high-speed spinners that force the honey out of the combs and into collection tanks. On the international market, the honey industry is valued at more than 10 billion USD annually, serving not only food but also pharmaceutical and cosmetic industries. Every drop of honey that reaches consumers represents a journey that is both artisanal and industrial, distilled from the tireless labor of millions of bees. Across the vast fields of Europe and North America, green peas, small, crisp, and sweet, demand a harvesting process timed down to the very hour, as more than 20 million tons must be gathered for the 2025 season. Specialized harvesters like the Oxbow series, equipped with cutting blades, conveyors, and separating fans, can collect up to 8–10 tons of peas per hour. The process runs seamlessly. At the front, blades slice close to the ground, pulling entire plants into the machine. Inside, beaters and airflow separate the peas from their pods, leaving only the vibrant green kernels. On average, each hectare yields 5 to 7 tons of fresh peas, and the harvest window lasts only 2 to 3 short weeks in summer. On the market, these peas are widely used as ingredients for soups, pasta dishes, salads, and stews, as well as in the form of frozen peas and canned peas destined for export. The fruit with a sweet fragrance beloved by more than 1 billion people worldwide is the peach. This year, global production exceeds 25 million tons of peaches and nectarines, with China alone accounting for nearly 70%, making it the undisputed center of the world's peach industry. Harvesting peaches is a process that demands great care. Because of their thin, delicate skin, most peaches are picked by hand. Farmers wear soft fabric gloves, gently twist the stems, and place each fruit into padded baskets to prevent bruising. Peaches are often harvested slightly firm, ensuring they remain fresh during long-distance transport. On average, a mature peach tree can yield 50 to 70 kilograms of fruit per season, while intensive orchards can produce up to 15 to 20 tons per hectare. After harvesting, peaches are quickly taken to packing facilities, washed, sorted by size and ripeness, then packed in trays or cushioned cartons for distribution. Today, peaches are not only a symbol of summer in many countries, but also a key ingredient in the juice, jam, pastry, and canned fruit industries, driving a global market worth billions of dollars each year. Cassava, also known as manioc or tapioca, is the world's third most important food crop, after rice and maize, feeding more than 800 million people every day. After about 8 to 12 months of growth, when the leaves begin to turn yellow, cassava roots are ready for harvest. In many regions, farmers still use hoes or their bare hands to pull up each plant, lifting entire clusters of long tubers from the soil. However, on large-scale farms, tractors and hydraulic lifters are used to uproot whole plants, shake off the soil, and gather them into piles. Immediately after harvesting, cassava must be processed quickly, as its starch content deteriorates rapidly. Most roots are sliced, sun-dried, or mechanically dried to produce tapioca starch, a key ingredient in the food, beverage, confectionery, and ethanol industries. Today, global cassava production exceeds 300 million tons annually, with Nigeria, Thailand, Indonesia, Brazil, and Vietnam among the leading producers, shaping an agricultural industry worth tens of billions of dollars worldwide. Over 2.5 million hectares of green cabbage across the world are entering the peak harvest season, covering vast fields from Europe to Asia. Each year, global production exceeds 70 million tons of cabbage, with China, India, Russia, and Germany leading the way, and accounting for more than 2/3 of the world's total output. Across fields spanning dozens of hectares, modern cabbage harvesters such as Assay Lift and Salmond begin their work. At the front, hydraulic blades slice close to the ground, neatly cutting each cabbage head from its stem. A tilted conveyor lifts the cabbages onto a sorting table, where workers quickly trim outer leaves, cut stems, and load them into crates or trailers. Each machine can harvest 15 to 20 tons of cabbage per hour, dozens of times faster than manual labor. At the processing facilities, cabbages are washed, graded, and shredded for food production lines. A portion is naturally fermented into sauerkraut, the signature pickled cabbage of Germany, Poland, and much of Europe. This year, global cabbage consumption is projected to reach 74.9 million tons, a slight increase from 70 million tons in 2023, continuing the steady growth trend of recent years. The storms of 2025 strike unpredictably, almost impossible to forecast. Leaves droop, many plants lean to one side, and millions of tons of crops lie buried in the mud, yet farmers still rush into the fields. For them, waiting for the sun is not an option. Just one more day of flooding could turn an entire year's work into decay right there in the fields. Under the heavy rain, each farmer bends low, hands scraped and muddy, searching for the fruits still intact. Harvesting in the storm has become a familiar scene in many parts of the world, from Florida and Louisiana in the United States to Bangladesh, the Philippines, and central Vietnam, where weather has grown increasingly erratic due to global climate change. According to the Food and Agriculture Organization, the frequency of extreme rainfall events during harvest seasons has increased by more than 40% over the past decade, causing estimated losses of over 123 billion USDs annually to global agriculture. Standing out as one of the most iconic symbols of autumn, the pumpkin becomes the opening character in our harvest journey. Across the United States, with Illinois holding the title of pumpkin capital, vast golden fields come into season from late September to November, just in time for the excitement of Halloween. Fresh pumpkin harvesters use sharp blades to cut through thick stems, while mechanical arms lift the massive pumpkins from the ground and place them onto conveyor belts. Rotating rollers and brushes remove excess soil before the plump pumpkins are neatly deposited into storage bins at the rear. With a continuous rhythm, thousands of pumpkins are gathered within just a few hours. Unlike fresh pumpkin harvesters, pumpkin seed harvesters have a more specialized design. These machines crush and separate the entire fruit directly in the field, sorting out the seeds through screening systems, while the rind and flesh are discharged back onto the soil as organic fertilizer. By combining these two technologies, American farmers not only meet the enormous demand for fresh pumpkins in holiday markets and food production, but also maximize economic value from the seeds, driving annual yields to more than 680,000 metric tons.